In this problem, we are asked to write down the E and B fields and sketch what the wave looks like for waves with different polarizations and moving in different directions. Let's go ahead and write down really quickly the general form. We have that the E vector, right, the E field is going to be some amplitude, E0, and then it has a polarization n hat. It has then a cosine and then a k vector dot r vector minus omega t, and the B field, right, is 1 over c, and then it is perpendicular to the E field and the direction of travel, and so n hat cross, or sorry, k hat cross E, like that. And so that's the B field, and that is the E field that we will be writing down. For the first problem, for part A, we are asked to write down the E field and the B field for a moving in the minus x direction with polarization in the z hat. So we can immediately write down the first part. This is E0 z hat cosine. I'm going to write down here minus x because the k vector is like that, but I need the length of the k vector. Length of the k vector, though, right, we know that omega is equal to kc, where c is the speed of light, and so the k vector is omega over c. So I get an omega over c here, and then minus omega t, and the B field then is going to have this same form, but we want a different direction on the z. We want a different direction on the here, and the k is in the minus x, so minus x would be that way, z is that way, and so minus x cross z is y hat, and so this is E0 over c y hat times cosine, and then the same argument. And those are my E and my B field. Now I want to draw this vector, and so I'm going to make some axes. So here's my x, my y, and my z, and my wave is going to be moving along the x-axis, but in that direction. And so I'm going to start drawing my wave along the x-axis, but in that direction. The E field, which I will draw in green, is in the z hat direction, so I'm going to draw the E field kind of in a sine wave here. And then the B field is in the positive y direction. I'm going to draw the B field in that same type of sine wave. And then I'm going to connect them. And so there, for part A, here is the forms, and there is a sketch of my wave, and the wave is moving, as I said, in the minus x hat direction, that way. Now for part B, we want to do the same thing. We want to write down the E and the B fields, but we've got a much more complicated problem this time. It's going to be in the k hat in the x plus y plus z direction, and the polarization is going to be in the xy plane. So, with the polarization in the xy plane, I know, right, that n hat will be able to be written as a x hat plus b y hat. And furthermore, we know that for electromagnetic waves, that n hat dot k hat must equal 0, and k hat is given to me. It's x hat plus y hat plus z hat, or at least that's the direction of k hat, which is enough for us, because what that gives, right, is n hat dot k hat is then a plus b must equal 0, or b must equal minus a. Therefore, I can easily write down n hat, if I normalize this, as 1 over root 2 x hat minus y hat. And so that is going to be n hat for our system. So I can write down E. E is going to be E naught over root 2 x hat minus y hat times cosine. And then I want to normalize. I'm still going to have this omega over c. I'm going to normalize this 1 over root 3 x plus y plus z minus omega t. And so that is the E field. To find the B field, I need to take the cross product. And so I need to take the cross product of n hat and k hat. And so this is k hat cross n hat. If I were to write this out in matrix form, right, k hat is going to be written as 1, 1, 1, n hat 1, minus 1, 0, x hat, y hat, z hat. If I continue, copy the first two columns over, 1, 1, x hat, 1, minus 1, y hat, and then I do multiply down, I get minus z hat plus y hat, and then if I multiply up, I get x hat minus z hat. And so k cross n is going to give me x hat plus y hat minus 2z hat. If I normalize that, I get 1 over root 6 x hat plus y hat minus 2z hat. Like that. And so this is normalized. So now if I go and I write down the B field for this guy, E naught over C times root 6 x hat plus y hat minus 2z hat, and then the exact same structure inside. And so those are the E field and the B field for these two. Now again, I want to sketch to this, and so let's go ahead and draw ourselves a great big set of axes. So now I'm going to mark the point 1, 1, 1, and I'm going to draw my wave going from the origin to the point 1, 1, 1. And so if that's 1, it's 1, this is 1, then I need to come out this far, parallel to the x-axis, right there. So my wave is going to go from the origin to that point right there. That is the backbone of my wave. My E field, if I come and I look at my E field, my E field points in the x minus y direction. So this is y, so it's going to point x direction and a little bit back. And so we start out pointing x direction and x minus y. So if I were to do x, so let's do this really lightly. So there's minus y, and so the x minus y direction is parallel to that vector that I just drew there. And so I'm going to draw parallel to that vector stuff like a sine wave. And then I'm going to do the same thing in the xy minus 2z will be xy minus 2z will be kind of in this direction. So I'm going to draw a sine wave. And then I'm going to come over like that. And here is my sketch of that wave that was described in the problem. Thank you.